Hello everyone, how are you doing? We are going to talk about some stuff to do with the web, and we'll take some stuff that we've got on premises at the moment and we'll show you kind of how easily we can move some stuff to the cloud and do some other cloudy type things with it. So we'll start out with a typical day in the enterprise. So companies decided that we're going to adopt a cloud first strategy. At the moment, we've got some web servers that are running internally. Those are on Windows. They could be on Linux, but just to make it easy for today, they're on Windows. Nothing is published externally. So at the moment, if a user wants to be able to access any of these apps, they need to be either actually physically on the network or they need to be connected via VPN. And coupled with this cloud-first strategy, users are wanting to work more from home, BYOD, the usual kind of suspects. So we need to make a decision. Okay? We can either stay as we are, we can look to move the applications to infrastructure as a service, we can choose to allow secure cloud access for those applications, or we can go all the way up and move into platform as a service. Okay, so what we'll do is we'll just kind of run through each of these and just sort of give you a few bits of food for thought on each. So if we stay as we are, then that's not going to address the cloud-first strategy of the business, and it's not going to help the users, right? Because we're not doing anything; it's just staying exactly as it is now. If we move the server over to infrastructure as a service in Fordway's cloud or in Azure or AWS, that's going to be meeting the business goals to move to cloud. But unless we do something else at the same time, we're not actually necessarily helping the users. Allowing secure cloud access, we can do that in a number of ways, and we'll kind of come to that in a minute. And then lastly, moving to platform as a service, well, that can meet the needs of everybody, and as you'll see in a minute, hopefully save you some money as well. Okay, so let's look at staying as we are and secure cloud access. So if we stay as we are, what OS is that web server running at the moment? If it's 2003 or 2008, well, you probably don't want those kicking around for too long. If it's newer, 2012 maybe, how much longer is that going to be in support, and do you want to carry on looking after that? What's it costing you to actually run that? Everybody thinks of the obvious things like, the licenses for the server, and if you've got like a SQL database, the SQL Server licenses. But you want to think like further back, what's it costing like in hardware, what's it costing in network and everything else. And lastly, the human cost. So, every server that you've got takes a certain amount of time to manage, no matter how efficient or well-oiled that server is. So there's things to think about there as well. Okay, so let's take a really, really basic example. So we've got a data center. We've got 10 physical servers in that data center, all running VMware or Hyper-V. Each of those servers has got 10 VMs on it, so we've got 100 VMs altogether. We've got 2 switches, everything's connected to the 2 switches, and they're 24-port bog standard switches. So if a host costs £10,000 for us to buy, and a switch costs £5,000 for us to buy, then this one web server that we're talking about is responsible for £1,000 worth of hardware cost and £83 worth of network switch port cost. And these are the kind of costs that quite often get forgotten, especially things like network and storage and all the other bits. If we choose to take the IaaS decision, then it's cloud first. We've moved it into a cloud, and it's not on our own infrastructure anymore. Perfect. But like I said, we're not addressing the users. We're only thinking about what the business has decided at this point. And unless we do something else, like a term that quite often gets used is re-platforming. So unless we, move that application actually onto a new server that we've built somewhere else, as opposed to just plain migrating it, we're probably not improving the security of it. If it's on an old OS, are there still security updates coming out for that kind of thing? We've decided that we're going to use IaaS, and we've decided that we want to use Azure in this example. So we've picked a VM size that fits the demands of our workload. So in this example, we're going to use a D2S V3 VM, and retail price that, if you use the Azure pricing calculator, that comes in just over £113 a month. If we choose to use a 1-year reservation using an Azure reservation, then that can bring that down to £90. So just for kind of the benefit of everybody that maybe doesn't know, Microsoft advertise list prices for all the VMs and services. What they also offer is this feature called Azure Reservations. And what that allows you to do is you can commit upfront to say, we're going to keep this VM running for either 1 year, 3 years, or 5 years. And the longer you commit, the cheaper it gets. So if you've maybe got like a core server that is going to be around for the next 3 years, commit up front and you get the savings. So to that virtual machine that we're going to build, we're going to attach a premium SSD. Now, the VM itself doesn't actually need premium SSD. But one of the gotchas with Azure that you can kind of miss sometimes is Microsoft provide an availability guarantee on virtual machines, 99.95% uptime. That only applies in one of two scenarios, okay? The scenario one is if you've got a VM that's part of an availability set, so you've got multiple VMs providing the same function behind like a load balancer or something. And the other option is if you use premium SSD. So if you're building a single standalone VM and you don't use premium SSD and that VM goes down, you're not eligible for service credits if that falls outside of your SLA. Because we want on-premises users to be able to access that virtual machine, we're going to need some connectivity. So in Azure, we get that using a site-to-site Azure VPN. So the minimum cost for a sort of sensible size VPN connection is going to be just over £100 a month. And then if we want to back up that virtual machine using the Azure backup service, that's probably going to cost us about another £12 a month. So the TCO for this VM, this one VM, is going to be about £223 a month. Now the thing to remember is that site-to-site VPN that is quite a sizable chunk of that cost, that's a shared cost. So if we deploy 1 VM, 10 VMs or 100 VMs, that's going to be split between them, much like we did with the switch port costs a minute ago. So allowing secure access. So this is a nice option because with this we can either stay as we are or we can use it with moving to IaaS. So we can use this either as kind of like a stopgap. So if we want to stay as we are but we want to facilitate the users a bit better, we can use this as a stopgap while we maybe think about moving to PaaS or doing something bigger and better in the background. So we can extend the application securely to the cloud so that people can access it remotely. Happy users, because they can access this app now from home without needing their VPN on all the time. But also happy security, because by publishing this application, as I'll show you in a minute, using Azure AD, it's going to carry on with all the investment in time and effort that we've put into things like conditional access. So if a user is required to provide MFA to access services that are published by Azure, they're still going to be asked for that. If we're restricting the locations that a user can sign in from, maybe to the countries that we operate in, that's going to carry on applying. So a little diagram of kind of how Azure AD App Proxy works. So we've got a user that's maybe on like a phone, tablet or laptop or something working remotely, and they want to go to a URL for a website that we've got published. That URL actually points to Azure Active Directory. Azure Active Directory accepts that request for the user's connection, and it's going to process any conditional access rules or anything like that that we've got configured there. Now this is where the good bit happens, is that on premises we have these servers called app proxy connectors. Now these, unlike sort of traditional publishing of a server where you've got firewall rules open to let things inbound, these servers are only ever connecting outbound. So what they do is they're constantly querying Azure AD to check whether someone is trying to access an application, and it uses like a service bus queue to check that. When it sees that someone is trying to access an application, it initiates the connection outbound. So you haven't got any nasty holes in your firewall making it look like a Swiss cheese, but the user can still get through to access the web application. Let's show you what this looks like. So at the moment, my laptop's connected to VPN. So I'm gonna hit a website that we've got running internally. It's really simple. It's just a little website that generates random passwords for our service desk to use. So I know no one believes in smoke and mirrors. So just to prove it, the IP for that password generator website is a 192.168. So it's an internal address. Okay. So what we're going to do is we're going to head over to the Azure portal, and of course that is prompting me to sign in, whereas earlier it was just letting me in. Okay, so what I've done is ahead of today, I have cheated a little bit. Ahead of today, just to cut down on time, I've actually already set up the application proxy server. So in Azure AD, we can see there that I've got a server running internally that's already running this app proxy connector. Doesn't take long to set up. It's very lightweight and it can run on server core as well. So we can have tiny little VMs that don't need much maintenance to actually provide that connector. So from Azure AD, we can hit this button up here that says configure an app. We give it a display name. And then we give it the internal URL. So this is the URL that people use to access the website at the moment. Okay, so the next bit, this is actually something that's kind of really neat about Azure AD App Proxy. So you can see at the moment there, it's automatically filled in an external URL of password generator, Fordway msappproxy.net. So that's Microsoft's domain that they use for sending all these requests through to. But what we can do if we want to is using custom domains that we've got registered in Azure AD, we can actually use our own internal domain. So users can carry on accessing the site using the same URL, and we can just publish that as a DNS record externally. But for now, I'm just going to leave that like that. So we can scroll down, we've got some more options, we can specify how we deal with cookies and session persistence and all that kind of stuff. But just for this, I'm just going to leave it all like that, and I'm going to hit add. And what that's going to do is that's going to create this app proxy. Takes a few seconds normally. So now that the app's created, it needs to be assigned to users so that they can access it. So what I'll do is I'll just quickly add myself to this so that I can access it. Okay, so that's me added. So what I should be able to do now is if I come in here, search for my password generator app, and if I grab this URL, all things being well, there's the same web application. The difference is now, instead of connecting to it internally using its internal IP, that's now going through Azure AD. So if I hadn't already been signed in because I'd just been using the Azure portal, that would have prompted me to enter my username and password for Azure AD. And I don't know if you saw when I signed in, I had to hit accept on my phone because MFA had popped up. Right, so this is great because we can apply this to applications that are internal now that don't have MFA. So rather than having to re-engineer the whole app to make MFA work, we can just stick this over the top and it's like magic. We've just made an application that we've got on-prem at the moment securely accessible, but it's still there on the server at the moment, okay? So we want to get rid of that server. I don't want to have to patch servers and wake up in the middle of the night when servers go down and those kind of things. So we want to move that to Platform as a Service, right? So Platform as a Service means we don't care about the OS, we don't care about the underlying, what it's running on. All I care about is my app and the code that's sat on top of it. So to give you a cost comparison, a standard S1 Azure web app is £68 a month. If we compare that to the 223 that we had earlier, that's quite a lot cheaper. The other great thing is that for that £68 a month, that is the price for the app service plan. You can run multiple web applications inside a single app service plan. So if you've got multiple web apps that are currently spread across a bunch of different web servers, potentially you can consolidate some of those down and make even more savings. The other thing about Platform as a Service is the backup costs peanuts. Because we're not backing up the whole VM, all we're doing is backing up our code that's sat on top of it. And the Azure Backup Service is natively tied into Azure Web Apps. So with a couple of clicks, backup set up, scheduled to occur however many times a day we want it to, and it just works. The other good thing about Platform as a Service is the high availability and resiliency is built in because it's Platform as a Service, whereas if it's infrastructure as a service, we have to build our own. There's other stuff we can do on top to make it even more resilient and reliable with things like Azure Load Balancer and Traffic Manager, but just at a basic level, on its own is fine. So what does Platform as a Service for Azure Web Apps look like? So if we kind of take the same example where we've got a user that's external on some kind of device trying to access this URL, by moving its Platform as a Service, the user's just coming straight in and hitting our web app. So we can make that accessible to them externally. But again, still if we want to, tie that in with our conditional access rules and everything else. If that web app is dependent on a database, we could move that to Azure SQL Server or Azure MySQL. Or, if we want to, we can spin up a VPN gateway and using what's called a service endpoint, connect that web app back through to on-premises so that it's still talking to our on-prem SQL server because maybe we're not ready to move the SQL side of it. Now the other option for this, if you don't want people to be able to access it from anywhere and everywhere, is we can actually configure a web app to block all external connections. So a user that's external trying to hit the public URL, maybe we deny them access and we say you can only access it from devices that are on-prem. So a scenario that this is really good for is maybe you've got a web app that is a bit confidential or has got sort of finance data or something like that in it that you don't want people to be able to see from anywhere and everywhere, but you still want to modernize it and move it to Platform as a Service. So with this option, we can move it to Platform as a Service, but people can only access it from internally. Let's take that same password generator website and we'll actually move it to Platform as a Service. Again, I've done a teeny tiny bit of cheating and I've already downloaded this Microsoft tool called Azure App Service Migration Assistant. So you start the tool up, it automatically looks in IIS and sees what websites you've got running and it can see that I've got this website here called Password Generator. So we'll hit next. And what it's going to do is it's going to scan the website in IIS and detect any problems. Now again, a little bit cheating beforehand. This is a PHP web app. Prior to today, it was actually generating a warning about multiple PHP versions being installed and that being unsupported. So not a big deal, fix that. We rerun the wizard, error's gone. You'll see that there is a warning there about the certificate. I'll talk about that in a minute. So we'll hit next. That's now going to ask me to authenticate against Azure, so we'll do that quickly. Okay, that's done. Okay, so I've signed in, it's detected the Azure subscriptions that I've got access to, so I'm going to choose our Fordway production subscription. We have to create a resource group for it to live in, so we'll call it Strategy Demo. What do we want the actual web app in Azure itself to be called? So we'll just call that Strategy Demo. Pick where we want it to live. So obviously we can pick from all the different Azure regions that are available. So I'm just going to choose North Europe for now. And then we've got the option to either migrate now or we can export the code for this in a JSON format that we can use later. So I'm just going to hit migrate now. Now, what this is doing is, just to be clear, it's not moving the website, so it's non-destructive, right? So by running this tool, it's not going to blow up the version of the website that you've got running on premises at the moment. It's taking a copy of it. So you can do this in advance. You know, if you're planning a migration, you've got change requests and things like that to raise, you can run this in advance, have the website ready, and then you can cut over your DNS records and your pointers to the website once it's finished. Normally it only takes a minute or two, and what you end up with is a pretty example of the site running in a web app. If anybody, oh, okay, there we go. And as I say that, it's finished. So you can say go to the website, and there we go. So you can see at the moment it's got the out of the box azurewebsites.net URL, but what we can obviously do is attach our own custom domain name to that to make that proper. But that is now actually running in Azure as platform as a service. Now, I appreciate it's kind of oversimplified. You know, this is a very simple website. There's not much going on in the background, but the point is that it's possible to quite easily pick stuff up and move it around into platform as a service. What the Azure migration tool doesn't do is it won't grab a copy of your certificate from the web server and move that for you. You need to go into Azure Web Apps afterwards and import your certificate. So while we're doing that, while we've got to manually go and import that certificate, let's have a think about certificates. So up here are 3 different types of certificate. Okay, Fordway website, that's using just a standard domain validation certificate. PayPal, that's using an organisation validation certificate, so you can see the green bar. And Halifax is using an extended validation certificate. Who knows the difference? Cost. Cost is the difference. This one costs peanuts. This one costs about 5 times as much, and this one costs anywhere from 10 to 20 times as much. Now, the problem is, users, they don't really actually care about the green address bar, right? So this next slide, the screenshots are taken from the latest build of Microsoft Edge. Right. 3 same websites, they've ditched the green bar. Microsoft's doing it, Chrome's doing it, Firefox is doing it. They're all getting rid of the green bar. So if you're buying EV certificates at the moment, stop, is the simple point, because you're paying 10 times as much for a certificate and you're not getting anything for it. The certificate authorities will try telling you that there's value in having EV certificates. There's not. Okay. My advice is to stop paying for certificates altogether and look at services like Let's Encrypt. Okay, so Let's Encrypt is a public CA. They offer free certificates. Now their certificates, the other CAs will try telling you that they're not trustworthy. That's not true. Any modern device now will trust a Let's Encrypt certificate. And Let's Encrypt is no fake. Okay, it was founded by Cisco and Mozilla, right? So they're a big company. Now their certificates are only valid for 90 days when you get them from Let's Encrypt. So initially you're probably thinking, oh, that means we've got to reissue these certificates all the time. But actually, Let's Encrypt support a protocol called ACME. And what ACME is it's a certificate automation protocol, so that if you're using something like an Azure web app that supports it, these certificates can auto-enroll. You have absolutely nothing to do. The other thing that I kind of glossed over on the last slide was that the CA forum that people like Komodo and Global Sign and all those companies are in, they're actually voting at the moment about whether to reduce the maximum lifetime of certificates to 13 months. So if you're buying 5-year certs at the moment, you won't be able to do that for much longer. My final point is to look at a type of DNS record called a CAA record. So most of you probably won't have one of those at the moment. It's really simple to set up, takes a couple of minutes. But what it does is it protects your domains from people being able to arbitrarily issue certificates from random CAs. So this screenshot I've got here, for the domain that I took this screenshot, it's only able to issue certificates from Let's Encrypt and Komodo. If somebody goes to Symantec or VeriSign and tries to issue a certificate, it's going to say, no, I'm not allowed. And the last thing is all the CAs now report certificates that they issue to a thing called a certificate transparency log. You can sign up for logging services, like there's a free one by a company called CertSpotter, and what it'll do is it will send you email alerts every time a certificate's issued against one of your domains. So it's kind of a good security tool because you can see if there's somebody out there trying to issue rogue certificates for your domains. And that is me done.